This is March 2020 Mathematics Paper 1, which is for both AS and A-level students. In the last video, we tackled question numbers 1 to 6. So in this video, I'm going to work some more question numbers. So here we are with question number 7. The diagram shows a sector AOB which is part of a circle with center O and radius 6 cm and with angle AOB is equal to 0.8 radians. So we have a sector AOB with center O. The radius is 6 cm. That is why we have OB 6 cm, and also OA will be 6 cm because OA also represents the radius of a circle. It is from center to a point on the circumference. So the angle is angle AOB is 0.8 radian. So you have to be careful. You are working in radian. You have to put your calculator in radian mode. The point C on OB is such that AC is perpendicular to OB. Now we have a point C which lies on OB, which lies on the radius OB, and we have AC which is perpendicular to OB. That is why they intersect here at an angle of 90 degrees or pi by 2 radian. The arc CD is part of a circle with center O. Now we have another arc CD which is part of another circle. The circle has the same radius as the sector OAB. That is, the center is O, where D lies on OA. D lies on the radius OA. Find the area of the shaded region. So this is the required area. So to find the shaded region, shaded area, we can take the area of triangle OAC minus area of sector OCD. So we take the whole area of triangle OAC and we subtract this part. We will be left with the shaded part. So area of triangle OAC. Area of triangle OAC. The triangle is a right angle, so we can use half base times height. This is the base OC and the height is AC. So these two are unknown. We have to find OC and AC. OC. So for OC, we can use cos 0.8, which is equal to OC adjacent over hypotenuse, which is OC over 6. Therefore, OC is equal to 6 cos 0.8. For AC, we can use sine 0.8 is equal to AC over 6. That is here. It is opposite. That is why we use sine. And therefore, AC is equal to 6 sine 0.8. Therefore, area of triangle OAC is equal to half base, that is OC, times AC, which is the height. So it's half times 6 cos 0.8 times 6 sine 0.8, which is 18 cos 0.8 sine 0.8, which is 8.996. This is for area of triangle OAC. Now for area of sector OCD. So for an area of sector, it is half r square theta. So this is the formula. it's half. Now the radius of sector OCD. This is the radius OC. So OC, we know it is 6 cos 0.8 to the square times the angle here, it is 0.8. So it's 18 cos square 0.8 times 0.8, which is 6.989. And hence we obtain the shaded area as 8.996 minus 6.989, which is 2.01 to 3 significant figures. Question number 8. A woman's basic salary for her first year with a particular company is $30,000, and at the end of the year she also gets a bonus of $600. For her first year, express her bonus as a percentage of her basic salary. This is quite easy. So the answer is take the bonus 600 over her basic salary 30,000 times 100, which is 2%. Second part. At the end of each complete year, the woman's basic salary will increase by 3% and her bonus will increase by $100. Express the bonus she will be paid at the end of her 24th year as a percentage of the basic salary paid during that year. So we have two things here. We have salary and bonus. And we are considering these two values obtained, these two amounts obtained at the end of her 24th year. So let's consider salary. So for year 1, her salary, basic salary is 30,000. In year 2, it will increase by 3%. So we have to take 30,000 plus 3% of her basic salary in the previous year, that is in year 1. So instead of doing all these calculations, this represents 100% and this represents 3%. So in all, it is 103% of the basic salary in year 1. So this is 1.03 times 30,000. In year 3, again we have to do the same thing. It is 3% increase of her basic salary in year 2. So instead of doing all this calculation, we just take 1.03 times the basic salary in year 2, which is now 1.03 times 30,000. So it is 1.03 to the square times 30,000. In year 4, it will be 1.03 of this amount. So it is 1.03 times 1.03 to the square. So we have cube times 30,000. And this will continue like this. So in year 24, her basic salary will be, so before that, here we can see that this is a geometric progression. First term is 30,000 and the common ratio is 1.03. And in year 24, her basic salary will be, we use a formula for the nth term of a geometric progression. And here we are considering in year 24, that is the 24th term. It is a r power 23. we are using this formula. UN is equal to AR power n minus 1. Here n is 24. So it's 30,000 times 1.03 power 23, which is $59,207.60. So this is her basic salary at the end of the year 24. Now for bonus. This is for salary. Now we have bonus. So bonus in year 1 is $600. In year 2 it is increased by $100, so it becomes $700. In year 3 it is $800, and it keeps on increasing by a constant amount of $100. So this one is an arithmetic progression. First term is 600 and the common difference D is 100. So the bonus at the end of her 24th year will be year 24. Again, U24. This time we use A plus 23D. The formula for the nth term of an AP is UN is equal to A plus n minus 1 times the common difference D. So it is 600 plus 23 times 100, which is $2,900. This is her bonus at the end of the 24th year. And the final answer, we have to calculate percentage of her bonus to her basic salary. So it's 2,900 over 59,207.60 times 100, and the answer is 4.89% or 4.9% to 1 decimal place. So you just have to identify whether it is an AP or a geometric progression, and then you apply the formula for the nth term, and here the nth term is the 24th term, and then you calculate the percentage. Question number 9. Express 2x squared plus 12x plus 11 in the form 2 into x plus a to the square plus b, where a and b are constants. This is completing the square. So this is covered in the chapter quadratics. So first of all, we have 2x squared plus 12x plus 11. So the coefficient of x squared must always be 1. So to do this, we take 2 as common and we factorize. We have x squared plus 6x plus 11 over 2. You have to be careful. You have to divide the other terms by 2. Now, to complete the square, we have x, this b, we divide by 2, so we have plus 3, and the whole to the square. This is c, remains the same, 11 over 2, and then we have to minus this term here, this 3 to the square. So we obtain 2 into x plus 3 to the square plus 11 over 2 minus 9, which is minus 7 over 2, and then we multiply 2 by x plus 3 to the square and 2 times minus 7 over 2, which is 7. So this is in the form of 2 into x plus a to the square plus b. Second part, part B. The function f is defined by fx is equal to 2x squared plus 12x plus 11 for x is less or equal to minus 4. So this is the domain for the function f. Find an expression for f inverse of x and state the domain of f inverse. So we have two parts here. First, an expression for f inverse of x. So this is done by writing let fx, let y is equal to f of x. So we have y is equal to 2x squared plus 12x plus 11, and we have to make x subject of formula. To do so, we have to write 2x squared plus 12x plus 11 in the completed square form. That is, we use part A. So we write this as 2 into x plus 3 to the square minus 7. So we obtain this is equal to y. X plus 3 to the square is y plus 7 over 2. And then x plus 3 is equal to, we take square root. This is plus or minus, and hence we have x as minus 3 plus or minus root of 11 plus 7 over 2. So next we write f inverse of x is equal to, so it's going to be minus, and here we replace y by x over 2. So we take minus because of the domain. The domain is x less or equal to minus 4. Because of the inequality sign, we have less here, that is why we have minus. If it was greater, we would have put plus here. And then state the domain of f inverse. So this is the second part. The domain of f inverse is equal to range of f. So we have to first of all know the range of f. So the range of f, if we draw the graph, so we know that it has a, from here, from the first part, we know that it has a minimum point minus 3, minus 7. So this is the minimum point, minus 3, minus 7. But here the domain is x less or equal to minus 4. This is minus 7. So we have to consider only part of the parabola as from minus 4. So this part only, the part in purple, and we have to find the corresponding y value. So when x is equal to minus 4, we have y is equal to, we have to replace in the equation. So we have 2 times minus 4 to the square plus 12 times 4 plus 11. This gives us, so we have 32 minus 48 plus 11. This is minus 5. So this part, this y value is minus 5. Therefore, the range of f is, so all these values are y greater than minus 5. So for this part, it is y greater or equal to minus 5. And here we are talking of the domain of f inverse. Domain, that is, we replace y by x. For domain, we consider x values. So it is x greater or equal to minus 5. This is the answer. So this is a parabola for x an element of R when we are considering all the values of x, we obtain this parabola which has a minimum point of -3 and -7. -3, -7. But here for f, we have a restricted domain. We are considering values of x less or equal to -4 only. So this is the graph for x less or equal to -4. Now we have to see what values y can take. So the smallest value that y can take is -5, and the other values of y will be greater than -5. So this is for the range of f. But here we are talking of the domain of f inverse. So domain, instead of y, we put x. So this is the answer, x greater or equal to -5. Part C. The function g is defined by g of x is equal to 2x minus 3 for x less or equal to k. For the case where k is equal to -1, solve the equation fg of x is equal to 193. So here we have x less or equal to -1, because we are considering the case where k is equal to -1. So fg of x, this is composite function. We have f of g of x, that is, we replace g of x by 2x minus 3, and then in the function f, we replace x by 2x minus 3. So we have 2 into 2x minus 3 to the square, because function fx is 2x squared plus 12x plus 11. So we replace x by 2x minus 3. 12 times 2x minus 3 plus 11. So we obtain 2 times 4x squared minus 12x plus 9 plus 24x minus 36 plus 11. So it's 8x squared minus 24x plus 18 plus 24x minus 36 plus 11. And we obtain 8x squared minus 24x plus 24x. This gives us a 0. 18 minus 36. This is minus 18 plus 11 minus 7. This is fg of x. Now we are given that fg of x is equal to 193. So we equate 8x squared minus 7 with 193. 8x squared is equal to 200. X squared is equal to 25. X is equal to plus or minus 5. But we are given that x is less or equal to -1. Therefore, we have only one answer for x. It is -5, because x is less or equal to -1. This is the domain for the function g. Last part for question 9. State the largest value of k possible for the composition fg to be defined. So for fg to be defined, so range of g must be a subset of the domain of f. So this is the condition for the composite function fg to exist. The range of g must be a subset of the domain of f. So this part, the domain of f, we know it is, in the previous part we saw that it was x less or equal to -4. The domain of f. Here it is the domain of f. It is x less or equal to -4. Now the range of g here we have function g. The range must be a subset of x less or equal to minus 4. So the largest value that k can take is when the range is minus 4. The largest value of the range must be minus 4. So we have 2x minus 3. So we don't know the value of k. So 2k minus 3 must be equal to minus 4. So 2k is equal to here 2x minus 3. We don't know the value for k. This is what we are going to find. 2k minus 3 must be equal to minus 4. And 2k is equal to minus 1. K is equal to minus half. So this is the largest value of k possible, because then we will obtain the range as minus 4. So minus 4 is a subset of x less or equal to minus 4. Therefore, we know that x must be less or equal to minus half for the function fg to exist, for the composition fg to exist. So I'll stop here. We have 3 questions which are left. These will be covered in the next video. Thank you for your attention.